I posted this program on Canvas, an example that calculates the greatest common divisor of two numbers. So the greatest common divisor is the greatest positive integer that divides two numbers. And let me first remind you what that is. You should have seen this in high school, but reminders are always good. So let's say you want to calculate, and there are multiple ways you can do this. You might have seen it this way. So let's say you want the greatest common divisor of 16 and 12, right? So you start with the smallest positive integer that divides the two. So 2 times 8 is 16, 2 times 6 is 12, and then again 2 divides the 2. So 2 times 4 is 8, 2 times 3 is 6, right? So then when you cannot further divide the 2 with a single integer, you take the product of the 2, and then 4 is the greatest common divisor of 16 and 12. Okay, and we'll see that we get this answer with this program. But let's look at the way that has been implemented in through recursion in this program, and it's a bit tricky. So let's see how this is done. So let's say that you want to calculate the greatest common divisor of 16 and 12. So we look at the modulus or the remainder, right? So we're going to use the modulus operator, the percent sign. So I'm just using Python's percent sign for the modulus. So 16% 12 is 4, right? And so the next thing you do is you're gonna. So now you can see that. Let's look at the function. So this is we're calling the function with two numbers, m and n, right? And then the base condition is that when n is 0, we are going to return m. Otherwise, we're going to return n over here. We're going to return the function with n in the first position now, and then m% n in the second position now. Okay, now let's see why this is being done. Now this is your m, right, and this is your n, right? So now we're gonna call the function with m and n, and this is your m% n. Okay. Now what we're gonna do is we're gonna take this 12, right? Let's use green. So 12, and then we're gonna calculate the remainder of 12 and 4, right? And then that is 0. So whatever we have over here is going to be our greatest common divisor. And let's see how the exchange is being done. So now you can see that whatever we have n over here takes the position of m. So whatever is first, I'm not going to write m and again, but listen to this carefully. So whatever we have in this position, okay, let's use blue again. So becomes our m, right? So and then whatever we have in the remainders position, right, now becomes our n, right? So now you see that exchange that's going on over here. So we have exchanged. So we're calling the function again with n in the first position. So this is n in the first position, that exchange, and then m% n in the second position. This is m% n, and this is in the second position now. And whenever the remainder is 0, this takes the position of m again, right? So then it is going to be returned as the answer. Okay, so this takes the position. The second one takes the position of m. So in this case, if there was a next step, in the next step, obviously this takes the position of m, because when you call the function again, let's look at the call of the function again. So GCD, so this, when you call the function GCD with 16 and 12, right? Now now in this case 16, this is 16, this is 12. Okay, we're trying to see how the recursion takes place over here. So when the function is called, obviously it doesn't go, because this is not 0, right? This is not 0. It goes in the else condition, and then it calls the function with now 12 over here, right? And then 16% 12 over here, right? Okay, So now, so this is our 4. This gives you 4, right? Okay. So now this is still not 0. So then what we get is it goes back and then it puts 4 over here and then 12% 4 over here. Now this gives you 0. And so this is going to be returned as the answer. Okay. And so that's where, let's write the other steps over here. So again, so this is 16%, 12, which I wrote earlier, which is 4, and then 12% 4, which is 0, right? So now you see that exchange that is taking place. Again, this is your M, this is your N, this is M% N. N takes the position of, takes the first position. You can see N is taking the first position over here. And then M% N takes the second position, M% N takes the second position over here. And then you call the function again with whatever is in the second position takes the position of M. So this takes the position of M, and then the percent of the 2 takes the second position. So this is again M% N, it takes the second position. And then since it's 0 now, the function is going to return M. And so let's test the function. So now let's run this. So we said 16%. So the first integer is 16, the second is 12. So we get the GCD to be 4. Let's quickly look at another example which has 3 steps. I'm just going to do the exchange part over here. You can think about the function call again using the same steps I did. So let's use both. So let's calculate the greatest common divisor of 40 and 24. Right. So it has 3 steps. So that gives you 16. Right. And then again we're gonna. So this is M. This is N. Okay. Let's write that. This is M. This is N. This is M% N. Okay. So this again takes the position, N takes the position of M, right? And then and you calculate, sorry, this is going to be 24. Let's just clean it up a little bit. So 24%, 16, that gives you 8, right? So again, N takes the position of M, and M% N takes the second position, right? Now, again, the next step, this is your, whatever is over here takes the position of M, so you get 16%, and this is M%, and so this takes the second position, and that gives you 0. And so your remainder is 8, okay? And so, so let's look at the program. So we did 40, and then 24 as the second number, and that gives you 8. Okay, so I know this is a bit tricky, right? Okay, so try to picturize again the function call with 40 and 24 by going through that exchange. That exchange is tricky, so go ahead, and if you think you need to watch the video again, go ahead, do it, and let me know if you have any questions about this.